Hi everybody, Josh here, and today I want to talk about a problem I solved from the Open Source Institute website. This is a website I used back in 2010. It's unfortunately no longer active. I did find a copy of it from 2014 on the Wayback Machine. But this is a site that offered programming challenges, and you could use pretty much any language you wanted to solve the problems. So you could use they offered you problems where you needed math or just basic understanding of programming, just to get started with the challenges and work your way up. They also had reverser challenges where they give you an executable and you had to reverse engineer it to get the answer to the problem. So for today, I want to talk about the Skyline problem. And this is a problem it took me about 2 years to solve, just off and on. It just took me a while to understand how to solve the problem and understand the problem. And that's because that's basically the core of being able to get there, is not necessarily programming, it's understanding the problem to be able to solve it. So the problem goes like this. You are to design a program to assist an architect in drawing the skyline of a city given the locations of the buildings in the city. To make the problem tractable, all buildings are rectangular in shape and they share a common bottom. The city is also viewed as two-dimensional. A building specified by an ordered triple with L, H, and R, where L and R are left and right coordinates respectively of the building, and H is the height of the building. In the diagram below, buildings are shown on the left with triples. And the skyline on the right is represented by this sequence. So we're taking these triples for each one of the buildings, so left, height, right, and that's represented by this, and then we need to convert that into the outline. So this format represented by this sequence. So you can see we have buildings of different sizes, buildings that overlap each other, so they would disappear in the outlines, and then bits of the buildings that stick out as well, that also overlap with other parts of the buildings. So it goes on to say, now in order to reach the next level on the way to Geek, and again that's just a reference to the website, you will have to take a file that has 500 triples and work out the skyline sequence for it. The sequence of numbers you get has to be treated like this. So they give you a 32-bit unsigned number, designated checksum, which is set to this large number. And then for each pair, offset and height, do the following algorithm on the checksum. So we need to first then shift all the bits in the checksum one bit to the right, and then get the value of the offset multiplied by the height, modulus 65,536, and then XOR the resulting number with the most significant 16 bits of the checksum. And then the answer is the final checksum at base 10 after applying the algorithm to all the data sequentially. And then they give you a short example of kind of what that is supposed to look like. So they say, at one point during execution of the algorithm, the checksum is this value, and the next offset and height values are 4 and 13. We take all the bits and we shift them one to the right. So we take our checksum, we convert that to binary, and we shift all the bits one to the right. Then we get the value of the offset and the height, so 4 and 13. Multiplied together, modulus 65,536, and then we XOR that with the most significant 16 bits of the checksum. The new checksum value is this, which in decimals that, and then we ultimately end up with this that would be our final answer in that example. So I'm going to go ahead and just show you the triples file, and they weren't lying, so there's 500 triples here, each separated by the pound sign. So we have left, height, and right, and it just goes on and on and on, so 500. So they give you enough here that you couldn't work this out by hand, not easily anyway. You have to write a program to be able to do this. So before I jump over to my code, this will be your opportunity to pause the video if you want to try and work this out for yourself. So I'll give you a second here, and alright, I'll go ahead and jump over to my code. So this is the script I wrote, and I used Perl to solve this. It's not a very long program. A lot of these solutions don't need to be long, but they just require a bit of cleverness to be able to work them out. So for this one, I just included my standard calls here for using strict, no warning, data dumper, which I use that for testing down below. I set up just some standard variables here to hold our heights and our triples and hold our checksum values. So basically, this program, or the script, is broken out into 3 pieces. So we need to intake our triples. We need to then process those to convert those into that second format where we just have, I guess, sort of doubles. And then once we have those, then we go down and we do all the checksum stuff on it. So that's what we're basically doing here. So we're, with this part, we're reading in our triples file, and I just read the whole thing in to a triples variable and just chop off the new line. Once I have that, I just take that whole variable, because I stored the whole thing in there, and split that apart by the pound sign into an array. So then each element in the array contains the three values. Once we have that, then we just loop through each of the values in that array, which again contain 3 values. So we're going through each one of those, and I split those apart by the comma, so we get our left, height, and right. And then we're looping through each one of those values, starting at the leftmost value. So we're starting at the leftmost point of the building, and we're going to work our way over. So we're saying for left, as long as left is less than or equal to the right, incremental left, just so we're looping here. And then we're going to take those values, and we're going to store based on the left value the height, and we're going to basically record the height with the most value and index that to try and get our outline. And that's what we're doing here. So we're storing this in this height index array. So I'm saying I have a check here that says, as long as if it's not defined, so it's the first time we've seen for this left, for the left, this height, we're going to go in, and then we're going to check again and say, are we on the rightmost side of the building? And that's what we're doing here. So if this was the building that we're on, if we're on the rightmost side of it, then we record a 0 as the height. And that's one I think admittedly that's what I had trouble with. I think I had a lot of this worked out, but this for some reason I just couldn't work out. I needed to get a 0 there to end that sequence for the right. If we're not on the rightmost side of the building, then we just, for that left, again we're storing this in an array, I just store that height. And if it was defined, so we saw, if we're going through this again and we see a height, that we see if that height is defined for that left, and then we check it again. So we say, okay, if we're not on the rightmost side of the building and the current height recorded is less than the new one, save that one. So we're doing here. So we say if left is not equal to right, and the height that we have recorded is less than the new height, record the new height. And we just keep doing that until we get through all the triples. I have some test code here that I wrote just to make sure I was recording all that correctly. And then we get down to this middle bit where we actually convert what we saved into the actual XY format, sort of the height offset, or left offset, left and height that they wanted. So we set up just a temporary previous height, set it to nothing, and then we set up a loop. So we're looping through everything that we saved in this index array. We're going through every single one, and we're saying, okay, if for the current index, if there's nothing there, because there very well could be nothing where there was no building, then we just we just skip it, keep going. If the current for the current index, if that height is not equal to the previous height, which on the first run through it'll be blank, then we just record that left and that height into our new output array, and then we record the height to our previous height, and we just keep looping through that until we have that all converted to that nice middle format. The last part of it is actually the easiest part of the program. The conversion was the hardest part. But once we have all of that done, then we just need to loop through everything that we saved in our output array here and just do all the checksum calculations and bit shifting on it. So we set up a couple of temporary variables here, and then we just loop through that output array. And we start with our checksum value that we just set to that sort of arbitrary value that we're given from the problem. We shift all the bits to the right by 1. Then from our output array, we split out the offset and height that we were given there. I did the same thing. I delimited those with the pound sign. And then I do the multiplication they wanted. So the offset and the height multiplied modulus 65,536. I bit shifted that by 16 to get the most significant 16 bits out of it. And then I XOR that with the checksum. And I keep doing that over and over again until we're done. And it has some just test data down here. So once we're done with that, then we can actually jump over to our terminal. Okay, sorry about that. Recording stopped there. I forgot that I had my spacebar mapped to my start and stop for recording. But the last thing we needed to do was just jump over to our terminal and just run our Skyline script. So as soon as we do that, we get our final checksum, and that's the answer to our problem. So I hope you enjoyed that and maybe learned something along the way. I do have a few more challenges from OSIX I'd like to share, and then I think I'll circle back to some of the Python challenges. So I thank you again for watching, and I hope to see you next time. Bye!